Welcome to CE405 Environmental Engineering 1, Module 3, Part 3. In the previous sessions of Module 3, we have already discussed about the sedimentation tanks, that is types of sedimentation tanks. The types which depends upon the shape of the tank and depends upon the flow of the tank. In the flow type, there are two types of tanks, that is horizontal flow tanks and vertical flow tanks. In the shape classification, that is first one is rectangular type, then second one is the circular type sedimentation basins. In this session, we are going to study about the circular basins. As the name suggests, the sectional view will be circular, that is, it will be a cylindrical tank with the central feed, and the flow will emerge out from the center and distributes over the periphery of the circular basin. The circular settling basins have the same functional zone as the long rectangular basin, but the flow regime is different. In the rectangular tank, flow enters from one side and it comes out at the other side of the rectangular tank. In the circular basin, the flow comes, the inlet pipe is fitted at the center of the circular basin, and the outlet will be at the periphery of the circular basins. When the flow enters at the center and is baffled to flow radially towards the perimeter, the horizontal velocity of the water is continuously decreasing as the distance from the center increases. Due to this decrease in velocity, the particle will settle down at the bottom of the circular basin. Then the cleaned water is collected from the periphery of the circular basin. Thus, the particle path in a circular basin is a parabola as opposed to the straight line path in the long rectangular tank. Sludge removal mechanism in circular tanks are simpler than compared to the rectangular sedimentation tanks. The first figure is the top view of a circular basin. From this figure, you can see that the small circle in the center of the figure is the inlet pipe, and flow comes out through this inlet pipe, and it is distributed over the periphery of the tank, and the cleaned water is collected at the periphery of the tank and distributed for further cleaning process or water treatment processes. The second figure is the sectional view of the circular basin, in which the central pipe is shown and the distribution is happening, and you can see the parabolic shape flow movement in the circular basin, and sludge can be removed from the center of the circular basin. Then types of settling tanks. Sedimentation tanks may function either intermittently or continuously. The intermittent tanks, also called quiescent tanks, are those which store water for a certain period and keep it in complete rest. In a continuous flow type tank, the flow velocity is only reduced and the water is not brought to complete rest as is done in intermittent type. In this type of settling tanks, that is intermittent type settling tanks, water is stored for a time period that is known as the design period, or that is different for different types of tanks. And in this time, there is no operations other than the settling in the water treatment process. This main difficulty for this process is that we have to consider an extra tank for the continuous treatment of the water, and we have to provide certain time for removal of the sludge from the tank and clean it, and then fill it with the raw water. This is obviously used in the small type of water treatment processes. Then the settling basins may be either long rectangular or circular in plan. Long narrow rectangular tanks with a horizontal flow are generally preferred to the circular tanks with a radial or spiral flow. Generally, two types of sedimentation basins, that is called tanks or clarifiers, are used. That is rectangular or circular. That is, we have already seen what is a rectangular settling basin and a circular settling basin. The length may also vary from 20 times that of depth in the case of rectangular settling tanks. The depth of the basin may vary from 2 to 6 meter. The influent is induced at one end and allowed to flow through the other end of the clarifier towards the outlet. This is the pictorial representation. That is, first figure is the top view of the rectangular tank. That is, the flow enters from one side and it comes out at the other side. And effluent channels are also given for reducing the velocity. Due to this decrease in velocity, the particle will settle down. The second figure is the sectional view of a rectangular tank, in which a small slope is given to collect the sludge, and sludge scrappers are also used for collecting the sludge. And the water, the cleaned water, after settling, the cleaned water is collected through the outlet. Then the design aspect, that is inlet and outlet arrangement. Inlet devices. Inlet shall be designed to distribute the water equally at uniform velocities. A baffle should be constructed across the basin close to the inlet and should project several feet below the water surface to dissipate inlet velocities and provide uniform flow. As the water enters into the sedimentation tanks through the inlet, then the velocity of water will be high. Then due to this increased velocity, the settling process will not happen, and to decrease the velocity and distribute the water all over the throughout the section of the circular tank, we will provide baffles, and these baffles will reduce the velocity. Then also it distributes the water throughout the section of the sedimentation tank. Then the outlet devices. Outlet weirs or submerged orifices shall be designed to maintain velocity suitable for settling in the basin and to minimize short circuiting. What is a short circuiting? It is the entering of the sludge that is sedimented or deposited or settled down at the bottom of the tank to the cleaned water. That is the short circuiting. So we have to limit or control the short circuiting. Weir shall be adjustable and at least equivalent in length to the perimeter of the tank. However, peripheral weirs are not acceptable as they tend to cause excessive short circuiting. So we have to collect the cleaned water to the further treatment processes, for the further treatment processes. So we have to provide collection at the periphery of the circular basin or the outlet of a rectangular tank, from where a weir is provided to collect the cleaned water and to avoid the short circuiting of sludge. And the circular basin. Circular settling basins have same functional zones as long rectangular basin, but flow regime is different. This we have already discussed. Then this is the actual picture of a circular settling tank, where the truss type circular truss type structure provided in the figure is for the sludge scrapping. Then the second process is sedimentation aided with coagulation. In the previous slide, we have already completed the plain sedimentation process. Then the next is sedimentation aided with the coagulation. In what all conditions we are taking this coagulation or the supplementary action of coagulation? What happens if coagulant is added to the raw water? If the suspended impurities are not in a position to settle down in the plain sedimentation process, we have to provide the sedimentation aided with coagulation. These coagulants are added into the raw water, then the suspended solids present in the water will agglomerate or small limbs are formed, small ball-like limbs are formed, and this will increase the settling of the sedimented particle or the suspended particles from the raw water. When water contains fine clay and colloidal impurities, which are electrically charged, are continuously in motion and never settle down due to gravitational force. Certain chemicals are added to water so as to remove such impurities which are not removed by plain sedimentation. The chemical form insoluble, gelatinous, flocculent precipitate, absorbs and entangle very fine suspended matter and colloidal impurities during its formation and descend through the water. These coagulants further have an advantage of removing color, odor, and taste from the water. Turbidity of water reduced up to 5 to 10 ppm and bacteria removes about 95 percentage. And this is the sedimentation aided with the coagulation. And these are the commonly used coagulants, that is aluminum sulfate, sodium aluminate, ferric chloride, ferric sulfate, and ferrous sulfate. Sorry. These two are given as ferric chloride and ferric sulfate. The first one is ferrous sulfate, then second is ferric sulfite. Coagulants are chosen depending upon the pH of water. Alum or aluminum sulfate is normally used in all treatment plants because of the low cost and ease of storage and solid crystal over long periods. Here we can see that the pH range, that is aluminum sulfate, is used for raw water having a pH range of 5.5 to 8. We are selecting the coagulant depending upon the pH of the raw water. Then in the common criteria, Kroman sedimentation process, alum is used as the coagulant because it is more cheap and its operation is also very simple. So alum and aluminum sulfate are used as coagulants in common sedimentation aided with the coagulation processes. By this, I am stopping this session. Take care. Next class, we will learn about the different components of a sedimentation aided with the coagulation process. Till then, take care. Bye-bye.